Here is a quick lab to demonstrate Modbus RTU communication from a laptop to an ABB ACH550 drive right there. That's the one right there. Okay, so all the details of the setup are right here. I've got the master is the laptop, the slave is the drive. The software that I'm using here is called Simply Modbus Master. It's a paid software. The communication is Modbus RTU, so it's coming in over those terminals. I have the Wago connectors to make it easy for me to network and to hook things up and change things around quickly. Communication, automation direct. I've got a converter right there. It's a USB 485M. And then because this virtual machine is a Windows 7 machine, I had to go on to Silicon Labs and pick up a legacy driver for it. The ABB software, I am using the software here to make it easy, and that is Drive Window Lite on a Windows XP machine. There are the details, and this is what we're working with. Let me go to the setup of the drive parameters. So this is node 8, 9600 baud. Parity is 8 none 1. The profile is the ABB Drive Limited. And once we get past that, these parameters down here, where it starts at 103, 104, 107, and 122 are important. I will explain those in a second. I'll start by explaining what this screen is. Here's your details for setting up the communication. We've got Modbus RTU. It's on COM port 2 on my VM, baud rate 9600. And the 88 data bits, 1 stop bit, and parity none. There's your node 8, and your registers that you read and write to are the 40,000 registers, starting with 40,001. Now, this is a read screen, so the software will be pulling values from the drive, and I have 8 registers being pulled, and the 8 start at 40,001. These are 16-bit registers. And then the function code is 3. And that corresponds to the mapping summary here. So the holding registers that we read and write to are the 40,000 series. And we have different functions that we'll use. We will do a function 3 to read the 40,000 registers. And then we'll also write either a single value with a 6 or a function of 16. These are function codes. And so over here, the function code is right there. So right now it's 3. So what is 3? So you're going to be reading from the coils, the registers. These are the values that it will be written, okay, read. So starting at 40,001, there's 8 of them. So here at 40,001 to 40,008. Those are the values in the drive that we'll read. The mapping of that is right here. So 40,001 through 40,008. The first one is the control word. And in our demo here, for this drive, we're going to start out with a 39. And I'll explain why 39 in a bit. And then when we turn the drive on to run, we'll change that 39 control word value to 47. Your reference, speed reference, the values are based off of a max value of 20,000. So 60 hertz is 20,000, 30 hertz is 10,000. We will enter that value. We're not going to worry about reference number 2. Now status word, all of these through 40,008 in our demo are read only. See, these are read write, and these values here are read only. So your status words, I'll explain that. That'll be coming in on 40,004, right there. Right now it's 4919, and like I say, I'll explain that. 40,004, and then you've got your output frequency, and here is your current, and then a few other values. Looking a little bit closer at these read-only values, the first one is your output frequency, and that is a default value, and that corresponds in here in the drive to these values. Now 103 is group 103, output frequency in hertz. Okay, and then 4 is current. Now we'll be adding a few more. I'm going to add the DC bus voltage, that's 07, and then I'll also put the value of the relay output, which is 22. So the way you'd enter these in, it's 122 for that. All right, going back down here. Here we see the values that are entered into the drive. 103 frequency, 104 current, 107 DC bus, and 122 is the relay outputs. So the control word, right now it's showing it from a previous time that I ran the drive, and at that time the control word was 47. Here's the binary converter. Decimal 47 is that in binary. Those are bits that correspond here. So 39 would be the values that are yellow. So when you first start up, you've got to have these 3 bits active, and also this bit active, and you change this 1 bit by changing the number from 39 to 47, and that's what we'll do when we start the machine. So before we start the machine, here's a demonstration of what we're going to do. We'll go from 39 to 47 for the control word. The speed reference is 10,000, which is 30 hertz. Full speed would be 20,000. That's 60 hertz. Reference 2 is not needed. Status word will come back when it's at 39. You'll see it at 4659. We'll go over that. Here's your 103, 104, and 107 and 122. And these are the group, group 53, number 10, 53, 11, 12, and 13. So right now, like I said, these values here are being read from the drive. Now, the program only reads it when I push the send button. The send is saying, I would like to read those 8 values from the drive. And so right now, I know the drive is not running, so you'll see the 47 turn to a value that I entered when I stopped the drive, which is 39. So we're going to send a request to read those values. There it is, 39. And your status is this number right here, 4659. Your DC bus is showing up as 319, and your relay output is 5. So when you look down here, the relay output number is 5, so you have the 3 relay outs, and you see that the middle one is off, which is running. One of them is ready, one is running, the other is no fault. So there's no fault, so right now it's at 5. Now we'll take a look at writing a value to the drive. So I'll go down here and push write, and this window comes up. So right now you see that the value is 6, so it's only writing one value. Now if we want to write more than one value, if we want to write 2 values, put 2 in there, enter. Now that 6 becomes a 16, which is right here. 16 is to write multiple values to the holding registers, whereas the 6 is to write one value to the registers. I see that currently the speed reference is 10,000, which equals 30 hertz. That's fine for our demonstration. So I'll leave that there, and I won't worry about writing to that second value. So let's put that back to 1. So our function code is 6. We're just going to write to this one value, 40,001, our control word. And right now it is at 39. So to start it, we will enter in 47. Okay, so 47, and then I'll send it. You might be able to hear the drive. Okay, right now it is ramping up. So while it is ramping up, let's push this send to see what the status word is. So right now the status word is 4663. Okay, that was while it was ramping. And it's done ramping, so let's do it again. We'll watch 4663 change to another number, 4919. Now let me explain the difference. Here's the difference. Here's your 39, and then 47 while it's ramping, and 47 when it's at speed. So it went from 4659 to 4663 to 4919. I used highlighter to point out the difference. So when it is off but ready to start, the orange is being activated. When it is ramping, the green is activated. And you can see the only difference here is that right here it's started. And then once it gets at speed or at set point, the yellow. So only one difference between the three, and those are the status words that are being read from the drive. So now that the drive is running, let's look at what these values are. The 47 is The value we put in to start the drive, 10,000 is 30 hertz. This one we don't use. I've got a value of 10,000 in there, but it's not being used. For 4919 is the status word, like I said right here, 4919. And then frequency is 30 hertz, and they don't have a decimal point in these numbers, so it's 30.0 is how you read that. Same way with the current. The current is actually 0.1 amp, and it shows up as 1. Your DC bus on this drive, it's about 220 volts coming in on a variac, and then the value that is being produced is 309 volts DC. And whereas before the relay out was a 5, now it's a 7 because all 3 bits are high. So the last thing I'll do is stop the drive. So we will write a value, and we'll just write the one value, changing the 47 back to a 39, and we'll send that. The drive is shutting off. They're ramping down. I'll get rid of this window, and we'll watch the values change. Your 47 will be a 39, your 30 hertz will be 0, your amps will be 0, and your DC bus might change a little bit. Here we go. Yeah, 39. There's your new status bit, frequency, all the values changed. And that's the basics.